Hello and welcome to IGPP Expert Talks. I'm Heena Goswami, editorial consultant with IGPP, Institute for Governance, Policies and Politics, New Delhi.
At IGPP, our work lies at the intersection of policy, technology, and society. Over the years, we have explored how digital transformations are reshaping not just markets or industries, but the very core of our social, economic, and political lives. Through focused research, policy dialogues, and publications, we have attempted to decode the complex digital ecosystems that are increasingly becoming part of everyday governance. In this journey, one thing has become clear. As conversations about artificial intelligence, digital governance, and data rights grow louder, we must also pay attention to what quietly enables them all: compute infrastructure. These are the digital and physical foundations that power everything from data processing to model training. They form the invisible backbone of our digital economy. Among the many components of compute infrastructure, data centers are perhaps the most critical and the most overlooked. Often seen as mere storage units, data centers are in fact high performance sites that process, analyze, and circulate massive volumes of data. Every time we interact with digital systems, it is these centers that do the heavy lifting behind the scenes. As India races ahead in its digital journey, the demand for advanced and resilient data infrastructure is growing rapidly. But with this growth comes a set of questions. Are we building fast without thinking long term? Are data centers ready to handle the complexity and scale of future AI systems? And most importantly, are we building in a way that is socially, economically, and environmentally sustainable? It is in this context that we see the need for a deeper, more grounded understanding of the infrastructure supporting India's digital ambitions. We're also seeing global conversations around data centers shifting. Countries are facing resistance from local communities over issues like water usage, noise, and ecological sensitivity. As India builds its own digital backbone, we must take these lessons seriously and design frameworks that reflect both our ambitions and our responsibilities. At the same time, the absence of a unified national policy framework for data centers creates serious gaps. Land acquisition norms, environmental clearances, taxation policies, and energy sourcing all differ from state to state, slowing down progress and creating inconsistencies. A national policy could offer coherence, ensure stakeholder alignment, and pave the way for responsible infrastructure development that supports both economic growth and environment resilience. To understand how data centers can be made more sustainable and how India can leap into a green future today, we are joined by Mr. Srinivas Varadarajan. Mr. Varadarajan is the founder and CEO of VigyanLabs, a startup engaged in innovation in energy management. Mr. Varadarajan is the inventor of the Intelligent Power Management Suite of software, which has enabled Fortune 500 companies to save over 1100 gigawatt hours of energy till date. He has multiple patents in energy management and over 26 years of experience in the IT industry. He has also served as the principal architect for the Aadhaar program.
To begin with, can you please introduce us to some of the issues related to data centers and how they are placing an increasing burden on already stressed natural resources like water, energy, and land? And how does the idea of green data center come into play, and what does it really mean in practice?
Let me look at, if you look at data center, today use three resources, right? Land, water and power. These are all scarce commodities. And in countries like India, we still already have scarce, right? These are scarce. And today, data centers consume about, I'll say 3% of the global energy. Okay, and it's increasing. And some countries like, Ireland is almost 25-30%. And some states and many countries, there's a big significance. And the way the data centers are growing because of AI coming in, energy consumption is going to increase much, much. Okay. Today, data centers consumes more energy than the aviation industry itself. We always think planes pollute. No, unfortunately, okay, do. And then, and this energy is increasing. Today, large extent today, globally, right? 70% energy comes from fossil fuels, right? Coal, petrol, and other things. And we already know about sustainability. We talked about CO2, that's still increasing. And next thing is, data centers also consume water for cooling purposes. Just to give a number, give some perspective, right? When you run any application or you download from a chat, if you do a chat, there's a servers running in your data center somewhere and storing some data and doing some computation that requires energy. So when you run a server generates heat, it gets hot. You need to cool them. So traditional people have been used chillers for cooling, right? Chillers for cooling. Unfortunately, historically, chillers use water for cooling purposes. They use clean water. They use what you say evaporative cooling. They use waters. So a server consumes 1 kilowatt hours of energy, right? Energy. To cool that load, you need 2 liters of water. Now you can imagine a gigawatt. We talk about gigawatt data centers. All these data centers we need today, the traditional way it's built, consume about millions of liters of water every day. A gigawatt data center consumes as much water as a small town itself, right? And we are always had, water shortage in the country, around the world, right? And every country had, the seasons of rainfall, there's a drought. How do you supply water to data centers, right? So that's where the issue today is, right? One is water is an important commodity. We need more of land. Second thing is also, we use a lot of energy. How do we reduce the consumption, right? Energy footprint. How do you reduce the energy footprint? How do you reduce the water usage or eliminate water usage at all? And how do you make everything efficient, right? From bottoms up. And this solving is not an easy problem because it's a multi-dimensional problem. And what is data center? It's a sophisticated building, right? You need to look at the civil engineering aspects of it. There is an electrical system, there's a mechanical system cooling. So you have got civil, electrical, mechanical. Then you have technology, servers, storage, compute, and GPUs, IT in one. So it's a multi-dimensional complex problem to solve. And there are efforts, around the world to solve this problem, right? Because one of them is, of course, there's an environmental issue. The second is a cost issue, right? Today, your energy cost is a significant part of your operations, and people are trying to look at reducing the operational costs to make it, viable, right?
How does then the concept of data center come into play, and what does it really mean in practice?
See, today is all your data, right? Whether you already talked about, whether you do a video, whether you want to do a WhatsApp, everything today, everything is about data, right? Your phone, your smartphone is useless if there's no network, right? Today, network. What do you do with a smartphone? It's a calculator and a camera. Other than a camera and a calculator, what can you do? You can't do it. It's literally useless, right? You can take a photograph. You can do something out of some time. So when you connect to a network, data gets stored in a data center somewhere. So what is a data center? Data center is a sophisticated building, right? Typically, buildings, there are standards for the data centers because you may have an earthquake, you may have a water flooding. So you need standards. But there are standards like Tier 3 uptime. So there are international bodies which get standards, and the standard tell you how a data center is to be built, right? So basically, just look at it at home, right? Your power fails, you have UPS. What if the power fails for 2 days? UPS cannot handle, right? The grid fails. So data center has to be designed to handle all these things, right? Let's say grid fails. How do? You have a UPS as a backup. UPS fails, you have a generator backup. What if the generator fails? You have two generators, multiple generators. What if one grid fails? You have multiple grids, right? So you basically data centers cannot go down any point of time, 24/7. So data center standards are there to make sure the data center never goes down. There are multiple redundancy built up. Again, the buildings have to be earthquake, waterproof, because it could be flood. So you have to take care of all natural calamities, right? Flood, extreme weather conditions, extreme heat, snowfall can happen, rain can happen. So data centers are designed to take care of all these kinds of failures. Or it could be network, right? So let's say somebody digs the road, fiber is cut. You cannot say fiber is cut. You have to have multiple fibers coming from different places, right? What if the undersea cable gets cut somewhere in the submarine, gets stuck up? So you have to take care of redundancies at every level, right? Nothing can fail, right? What if one server fails? Your redundancy, data gets corrupted. So data centers are sophisticated systems where nothing can fail, right? Just like I will just give an example, like an ICU. It's the most sophisticated ICU. ICU can shut down when there's no patient. Data center data is always there. You can never shut down, right? You can never shut down. So you can think of a critical system, right, which cannot go down for even for a second, right? It can't go down for a second. It has to be up and running 100% of the time because the society is dependent on it, right? Could be everything today: a railway reservation system, a airline reservation system, a Swiggy's of the world, Zomato's of the world, a OTPS bank, everything can come, right? Even if the network is a little slow for a second, you get anxious, right? Stress gets built up. So data centers have to be designed to handle all kinds of failures. Tomorrow there could be earthquake. What do? You have a data center in one more region, right? Far off region, different seismic zone, so that there's redundancy available. What if some geopolitics, something goes wrong? You have across continents. So data centers are designed to handle all kinds of failure, right? As I talked about network, power, flooding happens, there's earthquake happening, tsunami coming. You need to take care of all these kinds of things. So data center is a sophisticated science. When you build one, you need to take care of all these so many parameters, right, into play, so that end users or the customers get seamless service at any point of time, anywhere in the world, at any time, anywhere, right? Should work, always work, right? Should never go down. But that's how it's a science which has evolved. The number of data centers are increasing tremendously. There's a strain on everybody, right? You have to build more and more data centers, right? Everything is getting full today. How do you build more? How do you get land, more water, and more power? There's a race against all these three natural resources, right?
Just today, I was reading that OpenAI has proposed building multiple data centers, and each one of which would consume energy as much as the whole of New York City, each one of them. And with such high energy consumption, and as you mentioned, that data centers globally are consuming around 3% of electricity and contributing heavily to emissions. How did you approach the design of AI's water-free cooling system and cement-efficient architecture? And tell us a little about the design and how does AI differs from more conventional systems?
Yeah. See, we have been designing large-scale systems, for a couple of decades, right? Working in this industry, like because Aadhaar was one, we designed the Aadhaar data center pretty much. There are many things we did there, optimizing. Basically, we should look at how does a data center use energy, right? And where all energy is wasted, can we save that? So our approach in data center was designing energy. Second approach was we said we'll completely go solar. So when you have a building, you know how much energy you generate, right? Example, the building we generate 60 kilowatt of energy, 60 kVA, that's it. Now, can I design everything from scratch, so that I don't consume what I can produce? That's the effort. So we started with the building itself, right? Can we design a building? We look at data center buildings, consume a lot of cement. And the normal buildings get hot, right? India being a tropical region, buildings get hot. So you need also energy for cooling. We said, can we redesign the building in a different way such that the building energy consumption is reduced naturally by using a different material? So we said, can we redesign? So we worked with a couple of architects. We found a different material for construction. So we said, why do the traditional way of building? Can we redesign the building? So from the civil architecture, we started with a couple of architects, and we gave them kind of guidelines. I don't want to be built the traditional way. So we said we built a building with 70% less cement. We got special bricks designed for the building, which actually keep the building naturally cool by 6 degrees. So when you keep the building naturally cool by 6 degrees, your energy consumption reduces, right, naturally for cooling purposes. Then example, we eliminated false roofings. Because false roofing we found waste 20% energy. So we said, why can't we do a different way? Because why are false roofing used to put cables and all that? So why can't we when you build a roof, why can't you put the pipes within the roof itself? So I didn't need extra space. So we saved over 2 feet of space, right, by eliminating false roofing and putting the casts in the roof itself by designing the building. Next thing was, I said buildings use a lot of energy, waste energy and also use copper by putting electrical switches and equipment. We said, can we design equipment such that the building does not have any switches at all when you use AI? So we did a lot of building automation when they designed the building. The building does not have any electrical switches at all. Because of which, what has happened since we built the building, last 3+ years, not a single light has gone down, nothing has failed because it's automated. So when you automate it, nothing breaks, right? So we reduce the amount of copper, plastic we use in the building, right? Building. The windows were designed especially with thermal insulation was designed so that the windows, the building is not like a traditional building with full of glass, with less amount of glass. At the same time, we get good amount of sunlight. So like this, every aspect of the building we looked at, right? From the civil construction, so the building be naturally cool without having to, because in a country like India, there are certain parts of the year in different cities, the building is in the colder climates, right? Cooler times in the winter and all. Can we switch out the air conditioning? Can we reduce the air conditioning? We did that. So by doing special breaks in the design. Next thing, we looked at the building electrical system, right? Electrical system. One is, of course, we use solar panels. We use solar panels. The solar panel we designed, we bought the high efficiency solar panels and we use it for energy. And we also energy storage, right? We long before anybody thought of, we use battery storage here for saving energy, right? Because solar works only during daytime. What about night time? So we use battery storage. At the time when we bought the best possible solar panels and then the battery storage systems. You also need a grid as a backup. Worst case, right? Something goes down. You have a cloudy day for 1 week. We can't store energy for 1 week, right? Of course, we have backup generators. Multiple generators are there. Backups are there. We also need a grid. So we looked at the grid system, right? We found when you use a grid, so the energy comes from a grid into a transformer. From the transformer, energy goes into multiple steps into a UPS and UPS to a server. Look at all the path from the grid to the server. Where are the energy getting lost? Can you do something? We found the transformers, traditional way people design transformers, about 15% energy is lost. So can we redesign the whole transformer? Can we went back to our electrical professor at the university and work with him for about a couple of months? Can we start redesigning a transformer which is more efficient and compact, right? Because our aim was not only to save energy, make space is also, right? Space is a real estate is very expensive in India. Okay. So we made a transformer which is very, very small, half the size of a smaller transformer, which does not make any noise, which can be maintained. And the energy losses in a traditional transformer is 15%, we reduced to 5%. 10% gone, right away reduced there. Then look at the electrical panels and the distribution system. So data center use something called like a bus bar. Just give a simple bus, look at the electrical system. Today we have a long wire going, right? In any street today, most streets you have a electrical pole wire going in. A wire, each house is a tap, right? Tap, you take a tap from there. So you can think of a data center is something like this. Instead of a wire, this is a big piece of aluminum or aluminum going in the data center. All the racks, take a tap from there. If you found this kind of a traditional design of using what you call as a bus bar, putting lines where either not safe nor energy efficient, they will lose a lot of energy. So we redesigned that. We don't use a traditional bus bar. From electrical panel room, every rack gets a separate copper wire. So by using this copper wiring instead of the traditional aluminum, again we reduce the energy losses. Almost literally zero losses there reduced. After this, next was a cooling, right? People use for water for cooling. Said our aim was that we should not use water. Why can't we use air-based cooling? So we said we bought the best air-based chiller in the world. We put it there, but we find it to suck a lot of power. So traditionally, data center we use a word called PUE. What does PUE mean? A server consumes 1 watt of load for energy to do some work. To cool, you need some energy, and there's some energy losses because UPS loses some energy. There's some energy loss in the transformer everywhere. Loss is there. So PUE talks about power utilization efficiency, right? That means if you use 1 watt of energy for your server, how much additional energy used for cooling or other miscellaneous purposes? Traditional data server centers have been 1.5 to 2. That means server consumes 1 watt of energy. I need to consume 1.5 to 2 watts of energy to run the data center. Said, can we 1.5 is way too high? Can we reduce it? So when we put the traditional air-cooled chiller, our PU was 2. That means double. So for server consume 1 watt of energy, the chiller is to consume equal number of energy. We said this not too good. So he said, can we redesign the chiller? We didn't make chillers. We said, okay, we work with the chiller vendors. Again, we use AI to control the chiller. So what is a chiller? Is a type of compressor. This is compressor. It's like air conditioning, right? Air conditioning. So can we use AI to control the compressors and the chillers, compressors and fans, automate the whole thing based on the load? Can we automate that thing? Yes. Our team was able to build an AI tool to real-time control the chiller, air-cooled chiller. And then when we put our AI engine to the chiller, the PU reduced from 2 to 1.2. 80% reduction in energy, right? Big one. So today, there hardly anybody in the country who is able to achieve PU 1.2 using a traditional air-cooled chiller. I mean, people talk about liquid cooling and other things are coming in the way, but air-cooled chiller is a most economical chiller, easily available. You can buy anywhere. Doesn't require sophisticated, easy to do. So people use water-cooled chiller because with the water-cooled chiller, you can do PU of 1.14 or 1.5. So with air-cooled chiller, we're able to achieve and exceed the efficiency of a water-cooled chiller. So today, as of today, with the current load data center, we are able to save, 6 to 7 million liters of water every year. And as we keep increasing, so we have created a template where we can use air-cooled chillers and run a small data center. We don't need a big one. We can make a small one because the traditional approach has been, unless you make it big, it's not efficient. We have created a small one. We started with 5 racks. We have about 30, 35 racks today, close to 40 racks today. Our efficiency is constant. With a 5 rack, we are able to achieve a PO 1.2, 40 racks, PO 1.2. We go hundreds of racks. We can scale in a modular fashion. A data center can be scaled modularly while maintaining the efficiency. Today, traditional approach has been, unless you build a gigawatt, you are not efficient. We have shown a new way where you can actually do a small one, keep on adding modularly, and your efficiency is maintained throughout, right? And our aim is to now, we have proven to the world that you can use AI to run a data center, not just data center being AI enabled, run AI using data center. And again, next focus was, you made chiller efficient, you made UPS efficient, you made, what about the servers? Look at any workload, right? Servers are on 24/7, but the load is not constant all throughout the day, right? Load goes up and down. Night we sleep. Yes, something runs in the background. Daytime, early morning, when you wake up, we make a phone calls. But there's a lot of idle period, right? Can we do? Why should the server be running? Shutdown is not the way, because shutdown is restart takes a lot of time. You can't bring it up when a load comes in. You can't bring it. Shutting down a server takes few minutes. Bring it up takes half an hour to an hour. We can't afford that. We can't shut down. But what is a server? A CPU and GPU. Many of them are there. Sometimes they are idle or idle, not idle. So again, we use AI to predict the load and automatically turn on the chips, right, in the servers when they're not being idle. When the load comes in, automatically bring it on using AI. So by turning on the chips on off automatically real time using AI, we're able to reduce the server energy consumption by 25 to 30%. So like this, every aspect of the system we looked at, right? Looked at which part of which equipment server consumes more energy. Can we make it efficient by using AI? The storage data consumes more energy. Can we design the storage systems which are energy efficient, right? Like this network, every component of the data center we looked at and redesigned, reinvented to make it very, very efficient. So today, Mysore.ai uses a very minimal amount of GPU, small footprint GPU, and then use a LLM which is highly optimized. See, one of the aspects is look at the electrical part, chiller part. You also look at software part. Software also is not written very efficiently. It takes up a lot of energy. So we looked at optimizing LLMs, optimizing the stack. So entire software stack for running a cloud we built ourselves, right? Physical server, of course, you have to buy electrically, because what is in our control is we did. Again, the software stack. For running a cloud infrastructure, we built the entire software, and software stack is, we have made it very, very efficient, high reliable, right? Today, Mysore.ai with the current workload consumes a few kilowatts of energy, zero water usage. And what we have demonstrated that anybody can build, the world can build a AI infrastructure which is highly energy efficient, which can be solar powered. You don't need water. It needs very little amount of land. And our feeling is that, because sunlight, like a country like India, sunlight is everywhere. We can build large number of distributed data centers, completely solar powered. You can go to you don't need you can buy a dry land, right? Go to the place where nothing grows. Why do you want to take agricultural land and kill our agriculture, right? Take a dry land. We don't need water. We have plenty of sunlight. You can build a self-sustainable data center. That's what we have demonstrated, right? And then we are building many more such today in India and around the world. And I think this is a way of building data centers in the future, fully sustainable, renewable energy powered, zero water usage, and highly energy efficient, right? Using minimal natural resources, right? Less amount of cement, less amount of steel, less of everything, right?
Now that is the success story. But what were some of the challenges that you faced in building such an innovative data center? And from the side of industry or policy, what were some of the hidden challenges that the story that nobody saw?
So policies that you say, policies that we didn't depend on any government policies. Simple, we didn't depend on anybody. So let us be independent ourselves, right? Ourselves, build ourselves. So when you try to build, every vendor said it's not possible, because we have to depend on. See, running a data center requires, of course, you can build everything. You have to buy equipment from people. Example, chiller. Vendor said it's not possible. So every vendor we said it's not. Everything say, okay, transformer. Somebody said it's not possible to build. So when we try to question things, people said it's not possible. So everywhere we said it's not possible, we have to find out a solution ourselves, right? Nobody said you can do this such a way, right? Air cooled chiller, no, it's going to be very energy efficient. It's not going to work. You can't make a data center which is 5 rack, 10 racks, very energy efficient. Everybody said it's not possible. So we have to actually work against odds. I don't think any single person said you can do this, right? Everybody is saying, every vendor you talk to, hey, I say nahi hoga. you are doing the wrong journey, you will fail, you will not work. So it's more of a, I would say, almost everybody discourages us from doing it, right? Until we have it, had it running, people say it's not possible. Even today, I think people say, I said, it's not possible. I said, where to come and see it? When people come and see it, oh, right, okay, is it possible? It's running here live, right? Live. And, because the history has been that, the story has been, it's like, remember the smartphone came before a computer, right? Big. People thought smartphone cannot do anything. Today, smartphone can replace a computer. Today, the same story. Right? A big data center is replaced by a small one, which is compact, energy efficient, and then okay, we have to fight hard against everybody, right? Everybody. Today, the government doesn't recognize a small data center as a entity unless you have 100 racks or consume 1 megawatt of power. So you're not encouraging efficiency, right? You're encouraging inefficiency. Saying 1 megawatt should be there, then only I will empanel you, or you 100 racks. So what you can do with 100 racks or 1 megawatt, we are able to do at a fraction of the space and power, right? I think that's where I think government has to relook at the whole approach. Why can't you recognize? Because as a country we are very diverse. 150 crore people. We need thousands of data centers. Right? We always talk about data is the new oil, right? When you have so many petrol bunks and gas stations and fillers, why can't you have thousands and thousands of data centers? Because as a country, our data center we have is very, very small. See, globally, there are 6,000 plus data centers. Probably close to 10,000. Our country has few hundreds only. We are 16% of the population, world population, but our data is, data center percentage is very, very small. And I think our capacity has to increase 10x, right? How do we increase that capacity by not even 10 or 20x in a sustainable way, right? Our approach has been to, share our knowledge and work with other industry. How do you create a sustainable data center so that, see, we are an agrarian economy. And we grow food, if you consume more water, we always have water shortage, right? Every year, whether in Delhi or Bangalore, every year we run into water shortage. And we need water to drink and for our plants to grow, for our own living, right? Not for machines to consume, right?
Do you see that in the global or in the Indian AI infrastructure landscape? Do you think that there's a trade-off between scale and sustainability? And something that you mentioned about how government views small data center, do you think a decentralized, purpose-driven model like Mesu.ai would
Yeah.
serve India's objectives more and also be able to challenge the hegemony of large tech corporations?
Yes, I think this is a way to go, right? It's a way to go. See, look at the security issue we had, 2-3 weeks back. Always telling one drone can bring down a data center, but it cannot bring down millions of them, right? Security aspect is very makes sense, right? Distributing data. What if data is destroyed? I said, you have insurance. Insurance can get the money back and get the data back. Always tell people, no, insurance cannot give a life back nor a data back. And if you lose data today, data is everything, right? And the only way to resilience from, of course, we started with not with a defense purpose, we started more from a sustainable purpose, right? Because nature is distributed, right? Everything in the world is distributed. Energy is distributed, right? So the biggest challenge we have is energy is distributed. How do you supply energy? The current grid cannot supply energy for the data centers, right? You have a 10 gigawatt data center somewhere. The coal plant is somewhere, the power plant is somewhere. Our grid is not designed to carry large amount of energy, right? So look at solar. Solar is distributed, right? Naturally, solar, if we have rooftop solar distributed. So energy by convention distributed. Why can't data be along with energy? You keep data at one end, energy at one end, you have to build a transmission grid, right? Why do you do that? If they're together, your problem is solved, right? We don't need to upgrade our transmission grid. I think that's the way for us to go, right? And we start spending billions of dollars in upgrading transmission grid, which is going to take a lot of time. Because in AI, we are behind the Western world, right? Only way for us to leapfrog is build it distributed, and you don't need any grid, right? Your grid, independent of the grid, you can build super fast. We have done experiments now. How we can build? 3 to 6 months we can build, hundreds and hundreds of data centers around the country, right? Which are sustainable, AI powered, and it's possible, right?
From your experience, drawing from your experience, I want to ask you that India at the moment does not have a comprehensive national data center policy, although states are coming with their own policies and offering incentives to build data centers in their territories. If a national data center policy were to be developed, what specific sustainability measures or drawing upon your experiences, what do you think should be some of the measures that should be essential in that policy? And what key components can be included to ensure that there's environmental responsibility, resource efficiency, and equitable infrastructure development that are embedded in the policy framework?
See, the policy look at water consumption, right? Put a metrics on the water consumption. Because see, data centers have rating, right? You can give rating. Highest rating to one who has zero water consumption, right? Because you have rating. So people understand, right? Highest rating should go to zero water consumption. Second, energy consumption efficiency, right? We should put a metric like talk about PUE. PUE as a metric, right? Why can't we, PUE, PUE? Because PUE helps you. One is water consumption, one second is PUE, right? So when you have a PUE, PUE 1.2, give a rating based on the PUE. People have 1.2, 1.3, 1.4, 1. Ultimately, we want to go to 1.1, right? So give a rating based, give a weightage on the PUE, water consumption. Then, how much of, sustainable materials you in the building, right? Building. Because ultimately cement cannot be recycled, right? Today, can you reduce the cement consumption, right? Can you reduce the cement consumption? Use sustainable materials in the building, right? So that's again one more weightage. And then I think we need to create few more metrics, right? Metrics, like example, AI, right? Just AI, looking at AI workload. How much energy you consume for doing AI work? Okay, token, watts per token, right? I've been talking around in many forums. Why can't you have watt per token, right? The energy efficiency. Let's put a metric. Green, just like today we have today, right? For example, air conditioning, you have 1 star, 2 star, 3 star, 4 star. Why can't we have 5-star rating for data centers? Consumers will understand, no? Put a 5-star rating. I want to, store my data in the world's most efficient. Let it be a 5-star or 7-star rating, right? Rate data centers are not, that's the way, because it's not it's easy to do the rating, but difficult to explain to all these parameters to consumer. It's too complicated. Common man can understand star, 7-star data center, 6-star, 5-star, and business can easily understand. I think because we already done it for vehicles, we have done it. We had 4-star, 5-star, 6-star rating, right? Safety rating and rating. We have done it for air conditioning, refrigerator. I think we just should start policy and have a star rating, right? Simple as that,
My last question relates to the larger IT landscape in India, and we see that there has been an uneven growth of IT services in India with various unintended consequences leading to challenges like water scarcity, overcrowding, unplanned infrastructure stress, as we have seen in cities like Delhi, Chennai, Bangalore. And these conditions raise serious concerns about sustainability of our current tech growth model. In your view, what should be done differently to ensure that the next generation of tech infrastructure and innovation, especially relating to AI, becomes a model for sustainable and equitable development?
Yeah, I think, we should see as India as a country, I said there's talent everywhere. See, one of the reasons for me to go to Mysore was to tell the world that you can go to a small town. There's no IT business people there. See, people inherently, let us leave the English alone. People are inherently in this country are talented. We not come from any elite institution. People are inherently smart. We just need them help, right? You need them to, I said, why do you insist on a language? I can speak in a local language, right? English is required only to communicate with outside the world. If you look at China, look at Europe, they all speak local language, right? Japanese, local languages. One is language should not be a barrier. I think with AI coming in, it's no longer a barrier today. Tools available. And if you look at today, luckily our country has so many engineering colleges and diplomas, universities around the country, right? We have 1,000 districts. Look at from a districts. Every district has a university or a college. There are very smart people out there. Smart people just need a little bit of training, right? So what we have done is all this technology, we have done a lot of technological innovations in a small town. All people locally, right? A majority of people who build this tool are local. So we try to hire from a local engineering colleges, universities we hire locally. Majority will hire locally. I think local talent is available. Plenty of talent available. It's just that we have always looked at tier 1 city metros, right? I don't think people relocate. I think there's plenty of talent available. We have demonstrated that you can build a hype, deep tech company in a very small town. And it's possible. I think throughout the country, I think government should start encouraging, giving stuff, SEZs in the metros should give incentive to build in tier 2 and 3 cities, right? They give allow SEZs and small towns, and I would say more and more, instead of having 4 metros, we have support hundreds of districts, right? Then it will eliminate population migration. See, it's impossible to plan for a city with 200 million, 20 crore. What will you do, right? 5 crore, 10 crore. Look at Delhi and Bangalore, Chennai. How much will you add infrastructure? You are burning the money in building more and more flyovers and metro. How much can you put the same money in tier 2 and 3 cities, right, in the country? People are happy staying with their staying home. There's no population migration. Local infrastructure is good enough, right? And they have a better quality of life. A small town like Mysore, it takes 15-20 minutes to come from office to home, right? People are happy. I think most of the people are willing to stay back. I think COVID showed us, right? You can work remotely, right? Remote work. Why move the people to cities? Move the work to where people are, right? And that's one of the things we have demonstrated that today, that you can actually go to a small town and build a high world-class product, and people are available. I think it's just a change in the mindset, right, of the companies and government, that I see most of the small tier 2 cities have decent roads today. There's national highway nearby, somewhere. Roads are good. There's rail, airport connectivity. You always, any small town you take is 1 or 2 hours from any airport today, right? They're fairly well connected today, with Udan coming in, very well connected. There's trains somewhere nearby, and the roads are decent. I think, traveling, even just like companies like Zoho, right? They are in Tenkasi, a small town from. I've been there to their campus. You are from, you're from Tuticorin Airport. You're 2 hours away. I think, if Zoho can do it in Tenkasi, we can do in Mysore. Many company could do in somewhere. I think it's just possible. I think, what I would require, like people like you, media, just tell the story that, people can be where they are. Companies can build, startups can be built in tech, deep tech companies can build in small towns. And India, we have plenty of talent. I don't think we should complain. We have a country with amazing talent, right? In every city has amazing, brilliant people. It's just not that they just because they don't speak English, don't come IT, doesn't mean they are good. They are equally smart.
I mean, what you said, that don't take people where the work is, but take work where people is. It's so
Yeah.
apt. And I definitely feel that the quality of living or the happiness index in tier 2 and tier 3 cities would be much better than metros of, I mean, all our metros. Thank you so much for joining us today and for your very insightful discussion. And thank you for telling us about Meso.ai and the amazing work that it is doing.